Hey there, Alex. This is Mr. Hanksman. This is the screencast for the level 4 extra credit. These are both different types of combination reactions. They're special cases. So this would be extra credit on your upcoming test. Okay, so I'm going to keep this relatively short, but there's two different types. So one thing, just so you know, one thing that they both have in common, other than just being combination, is that they both have water as a reactant. So when you see water as a reactant, that's kind of a tip-off that it's going to be one of these special cases. So the first one here is we take a metal oxide. So any metal, any positive ion mixed with oxygen. Now when you react that with water, it's going to make a metal hydroxide. Now if you remember from chapter 9, a metal hydroxide is a base. So it's going to be this positive ion with hydroxide or OH negative ions, and they make an ionic compound. Okay, so I have one example for you here. Like I said, it forms a base. Okay, so here's your metal oxide with sodium being the metal in this case, so it's Na2O, and then when that reacts with water, we're going to take the metal and we're going to put it together with hydroxide, and then you have to consider the charges. So sodium is +1, hydroxide is -1, so it's just going to be NaOH, and then of course you have to balance it at the end, so you'd have to have that coefficient 2 for the sodium. Okay. Alright, so that's the first one. You take a metal oxide and water and you turn it into a metal hydroxide. Okay, now the other type is when you take a non-metal oxide and you combine it with water. Now in this case you're going to make an acid. Okay, so when you take a non-metal oxide, the anion that's going to be in the acid comes from the non-metal and oxygen. All right, so when you look at your ion list, so you have things like sulfate, sulfite, phosphate, phosphite, those types of polyatomic ions, a non-metal with an oxygen. Okay, and then you have to determine what the charge of that polyatomic ion is, and you have to add enough hydrogens to balance out the charge of the acid's formula. Now, when you do this, you're going to look at the nonmetal, and there might be more than one choice. Well, you want to take the polyatomic ion that has more oxygens. So I'll show you in this example right here. So this is our nonmetal oxide. So phosphorus is a nonmetal, so P2O5 is a nonmetal oxide. You combine it with water. Okay. Now when you write out the acid, it's going to start with H, but you have to determine what the anion is by looking at this nonmetal oxide. So it's going to be made out of phosphorus and oxygen. So your choices are phosphate and phosphite. Phosphate is PO3, -3. Phosphite is PO2, -3. So you want to pick, I'm sorry, phosphate was PO4, phosphite is PO3. Okay, so you want to pick the polyatomic ion that has more oxygen. So in this case, you want to pick phosphate. So you always want to pick, it comes down, you always want to pick the 8. The 8 has one more oxygen. Okay, so then of course you look at the charges. Phosphate has a -3 charge, hydrogen is +1, so you would need 3 hydrogens to balance out the ionic charge, and then of course you have to balance it. So those are the two types of special cases. All right, have a good day.